Part 3 of our forces math is looking at calculating the change in velocity. So we have an equation of that triangle V, which in math we say delta V, so we can say that in science as well, delta V equals G times T. So it's worth writing out that you understand that delta V means change, and if you have change in velocity, you know that it's V final minus V initial. That will help us as we break down different problems. Oftentimes you're going to be solving for the final velocity, and so you need to know how to break this out. Gravity is our G variable, and that is 9.8 meters per second squared, and then time is measured in seconds. So the example problem here is number 8 in your notebook. So it reads, a penny at rest is dropped from the top of a stairwell. What's the penny's velocity after it's fallen for 2 seconds? Using our critical reading strategies, we're going to identify what we're solving for and figure out our variables. So I like to circle that word velocity and identify that that's our final velocity, and then identify if it's like what the other variable is, and that it's fallen for 2 seconds, so that's time. When you look at your equation for velocity, what you want to do is identify that you are showing gravity times time, right? Velocity equals gravity times time. And so when you're looking over here, it seems like you don't have enough to solve, but do remember that gravity is 9.8 meters per second squared. So when we go set up our equation, it's worthwhile to note that you can turn this into a power triangle as well. So the change in velocity equals gravity times time. And so we have our problem looking like this. So V final, this is why I like to break this out, minus V initial equals gravity times time. When we plug in our variables, we can look and see that we have solving for V final. We started at rest, so our V initial is 0, equals 9.8 meters per second squared, which is our gravity, and then 2 seconds, which we got from our problem. What you want to do is go back and ask yourself what you're solving for. So in this situation, we're solving for velocity. Because I know velocity is distance over time, I know that my units need to be in meters per second. So then you come and look over here, and you're going to identify, can I cross out variables to get to meters per second based on how I have my equation set up? And in this case, you can. You can cross out those seconds. You know you've done it right because you're left in meters per second once you actually do the math. So now what we can do is go ahead and multiply, and I think the biggest thing here is identifying this is 19.6 meters per second. If I am solving for velocity, just like in our motion unit, I need to make sure I'm including a direction. So 19.6 meters per second down. So there's your notes on calculating change in velocity. Do the rest of the problems in part 3 now.